Okay, so this is my review of the southeastern section. Um, it was pretty fun. I mean, I had a good time. Um, I was right, I guess. So um, it was pretty cool. I didn't submit an abstract, but I do have the epitome, which I guess is also means abstract. Okay, so I'm gonna start off with this open planetary session with Mr. Greg Gubar, and he talked about falling felines and fundamental physics. I wonder if we'll get anything if we look for this. Oh yeah, nice. All right. So this is a dude.
Blackstone Publishing
pretty cool.
presents Falling Felines and Fundamental Physics by Greg or download. Sabrina Fluff. Cats have developed an intelligence that allows them to running. When she was brought to the vet, her only injury from the fall was a hairline.
Okay. But yeah, he talked about how it was really hard for physicists to explain how cats worked. It was pretty funny. And it was kind of like a great way to talk about how not everyone, it was a great way to talk about how, you got to kind of keep an open mind. And I think it probably showed that it matters much more how you phrase the question rather than anything else. After that, planetary session, we had the break. Let's get here. And then we had, you got to choose which one you wanted to go to out of these sessions right here. And I didn't really know which one to go to, so I thought that this one sounded the coolest, quantum theoretical physics, and I'm glad I did. The first one was performance analysis of multi-angle QAOA for quantum analysis, and it seemed to be that multi-angle is better than consider the scalability of multi-angle with respect to the number of QAOA layers. We found that MAQAOA is available to significantly reduce the depths. It was very interesting. It was not optimal for the minimization of the total QPU time. Different optimization and initialization strategies are considered and compared for both. Among them, new intelligence strategies suggest this is able to consistently and significantly outperform random initialization used in previous studies. He is one of the people I talked to, actually. Google Scholar. Yeah, he's pretty cool. Quantum chemistry. Interesting. He cited this? No. No. What? They just spelled his name wrong or different. Well, he's one of the people I talked to, and I don't know if I would say I convinced him, but he was definitely, I talked to him. He was a very nice guy, man. He quantum, I think it was Neilman. Let's see, images, shopping. This one, what year is this? Oh yeah, this is the one, Chuang, because that was, yeah. So he recommended this book to for the introduction to quantum computation and quantum informatics. So if you want to learn about quantum computing, like I was interested in, this is where he recommends to start. And so, keep that up. I don't know. I'd have to ask him if I convinced him. I think we're the friends on LinkedIn. But I think I definitely piqued his interest on it. And he definitely gave me some things to think about with it. Like, he's the one who brought up, he's the first person I talked to about it and tried to pitch to it, actually. Where am I? Hang on. No. Oh, it's right here. He was the first one I kind of pitched this all to. And pretty cool. A lot of ozone stuff. This is the one I think that he presented. Yeah, that's definitely the one he presented. Molecular dynamics on quantum. This is cool. I can't believe yeah. So, a quantum physicist. I think I convinced him that I was right. For him, it didn't matter. And for most people, it won't matter. But it does matter if you want to know science. If you want to get to the bottom of what is nutritional physics or nutritional science. If there is such a thing, there is. Okay. This is an algorithm for general combinatorial optimizational problems. Huh. Read this. Okay, but we're here all day. We go through everyone's articles. He helped me realize that like there's a measurement philosophy. Calories, technically, if you define something in nature at a repeatable standard, it could be its own measurement. It's just whether or not that measurement is appropriate for what you're trying to measure. And so in that sense, it really helped refine my argument that it's because if you check my previous videos, it says calories don't exist, but that's not technically true. What is technically true is that calories are bad physics when applied to nutritional sciences. It doesn't make sense how they are applied as combustion to nutrition, because that's not true, and that doesn't make sense. So I think I was able to really convince people here of this. Yeah, he was the first one I talked to and helped me refine it into that argument, so I really appreciate that. And then another quantum talk that I did not understand, but just, I'll pull them all up. Yeah, they talked about things and way over my head. This part, way over my head. All of this stuff. And so I sat in on it and just tried to be exposed to this information, so that way it'd become more familiar over time. Like, it wouldn't, the next time I would see it, it would just be a little bit easier to digest. The words wouldn't seem so big and scary. And maybe start seeing some early patterns in associations. I don't know. I'm not highlighting anything specific. Bosons and fermions in one dimension simulate quantum particle trajectories in infinite square. Well, this was interesting. This is by he was a teacher. It felt like a physics teacher that taught just the most crazy advanced physics you could think of. Stephen Murphy. He was a good presenter. Retired. That is not who that is. Stephen Murphy. No. Let's see. Okay. Maybe. I don't know. He didn't look like that, so hard to say, really. No, definitely not. Not the same one. Anyways, cool guy. Let's go move on. Then our next, then we had 12 o'clock, this student lunch. I think it was just lunch, yeah, decent. So this one went to, I went to everything biological and medical physics. So, democratizing, quantitative phase microscopy enables high-precision, label-free imaging by measuring optical path length variations in transparent biological systems, offering affordable, non-invasive alternates to current commercially available quantitative phase microscopy techniques. Our approach leverages enormous non-linear optical properties and birefringence of liquid crystals. Polarized camera creates a stable profile for I don't remember this one. I probably should have done this closer. It is Wednesday, and this was almost a week ago. Measure refractive power of progressive orthomatic lenses. Can't remember this one. Sorry, guys. Oh, but Shobita, sorry, I want to pronounce that. She is the nicest lady ever. Hang on, no, let's see if we can find her. Yes, she's awesome. She is such a sweetheart. She is convinced of my theory, so I can actually say I'm. And if she corrects me, I'm so sorry, but I'm pretty sure I've convinced her of my research, or at least she acknowledges that my research seems valid and thorough. And she is interested in male fertility because it isn't very well documented. So hybrid mechanics. Is this what she? Let's see. Sure. Boom, boom. Yeah. Sperm motility. This is what she talked about in the lecture. Gosh. I don't want to misspeak on it. Flow generated in the surrounding fluid by moving sperm does not balance out the forward momentum of the sperm. Since backward propagating wave and contact point speed pulse suggests flow generation from the flagellum to better understand fluid's role in motility mechanism of the fluid field, sperm and 1%. I think she was even going to try and work with the lab at the university to look at this motility flow even more, with more detail, to really get a better understanding of it. And while we were at UNC Charlotte, because they have one of the best optics physics labs in the country. I think there's like a competition maybe between them and like 7 other people. So it's pretty cool. I wonder, does it also talk about convergent flow. So like there was also like sperm move better when they work together. Boom, boom. Let's see what it talks about here. To fertilize eggs, the wall is known. Sperm swimmers. Yeah, sperm is thought to be swimmers, but it comes from swimming, but it actually doesn't. The surface, it actually climbs the surfaces of the female reproductive tract, the womb, and maybe that's where it even fertilizes the egg. But they also swim with group motion. That's like a school of fish, like swimming through. It was pretty interesting, and she is awesome. She said she was going to help introduce me to some other doctors, and I hope that's able to go through. No one can control the schedule of other people, though. So I just really appreciate everything she did for me while I was there. Just her kindness. She was the sweetest. It was really great. Yeah, there were a lot of really sweet women. And really sweet guys too, who were like listening and like supportive. It was super nice. It was. I was a little bit awkward, but it was. They were so sweet. Radio effect on nematode. This one was really cool. I do remember this one. They were basically investigating the Havana syndrome, where they think that high frequency radio waves were interfering with U.S. diplomats, and I think some other diplomats, just people in the general area. And so they tried to see that can other sensors be initiated, can like photoreceptors be triggered by radio waves, and they did study radio waves. There was something about their study that was a little bit different. I wonder if this is actually published. Okay. Anyways, this was pretty interesting, and it appeared that the blue waves and the blue radio waves and the blue waves and the radio waves, had similar profiles and energy. So that's these down here, but then on the other side of visible light, on near the ultraviolet side. And immediately, because I'm not very experienced in physics, I thought that blue was lower wavelength initially. I think that most people do falsely, and not infrared. But it's still, so it like peaked, dipped, peak, maybe dip, peak, I don't know. But it was an interesting reception, an interesting pattern. And so, yeah, I thought that was cool. Let's see, quantum dots from producing cancer cells. This one was interesting. I asked a question that got answered later on. I think I asked such a fundamental question that it didn't have to do with the actual details of the study, that it kind of might have tripped him up for a second. He knew what he was talking about, though. And this one, I think, was his instructor, and she clarified that like cancer cells have their own they have unique receptors that we understand, and because we've already been able to identify what's unique about those receptors, we can attach things that will bind to those unique receptors to identify cancer cells. But sometimes, like these quantum dots did have altered, or they weren't always uptook by cancer cells, but they did have optimal targeting. It was like 20, couldn't tell you the measurement they used, but 20 was the number. I think it could have been 40, so I don't really know. MRI deep learning networks for classifying. This was cool. this was like to try and look for brain tumors and stuff. And he said it a good classification accuracy. So this is my problem with this whole thing. And I asked him later, and he said medical clinics won't use these kind of devices unless they have near 99%. But I've heard Whisper is already doing hallucinations, and people are trying to implement them, and people can sell things, especially when you say it says it has a good classification accuracy, so I could sell this system to you for $25,000, even with it is down this low. He was an undergrad. I think he thinks that the system is hopefully set up better than I think it is, as someone who's 10 years a senior. And so I still do worry about this wordage on the conclusion, good accuracy, because unless this is really like, this has to be like 98, 99, 7 with condition, under supervision, under here, before I would say it has good classification accuracy. So but a fun study. It was pretty cool. So this is where the future hopefully is going, to help identify. I think the best way to do this AI imaging is to do early access. The goal for his imaging is to replace surgery or biopsy. And so it's a non-invasive way to try to identify cancer without biopsy. But I mean, would it just help identify things that are already there, but would those be hard to spot? I guess there's so much brain tissue and everything, so hopefully the machine is looking for a pattern that it doesn't hallucinate itself into, or just have a missing data point of, and not falsely thinking that there's cancer everywhere that they have to biopsy, which is why it'll have to be like ground truth to other biopsies. There should always be an anatomical marker for cancer. That's one of the things that makes it cancer, is it's different than other normal functioning cells. Hopefully that these will probably identify concern sites to monitor, I guess, and then come back for regular scheduling and maybe get us closer. But anyways, it's definitely not just like a fire and forget kind of thing. It's got to be carefully integrated. Coffee break.